in part one of this video, we're going to be getting an introduction into the properties of matter. The properties of matter we're going to be discussing are mass, volume, and density. So let's have a look at what those three things are. Mass is the amount of matter that's inside of an object, so the amount of stuff inside of something. Volume, the second thing we're going to look at, is the amount of space that an object takes up. Density is the third, and that is a combination of the first two. That is an amount of matter in a specific amount of space, or we could say it's the amount of mass in a given volume. The first one we'll look at is mass. Remember, mass is the amount of matter inside of an object. We can't weigh or we can't measure mass using a scale, because a scale measures the amount of gravitational pull but tells us nothing about how much matter is actually inside of an object. So to get the amount of mass in an object, we need to use a balance and balance that object with another object of known mass. And when the two objects are balanced, we'll know the mass of the object that we were trying to find. The units that we measure those in are grams and often milligrams. As you can see below, we have two rectangles that are both appear to have the same amount of volume, but they're labeled 10 grams and 20 grams. So they can appear to be the same, but they can have a different amount of matter inside of them. So the one labeled 20 grams we know has more matter inside of it than the one labeled 10 grams. Next, we're going to look at property number 2, volume. There are a few different things we can measure volume of. So the first thing we're going to start out with is liquid volume. Liquid volume is measured with a graduated cylinder, and its common units are liters and milliliters. Looking at the picture below, you can see a graduated cylinder, and you can see that the proper way to use a graduated cylinder is to set it on a flat surface and get down eye level with it, so you can look straight onto it and read the actual volume instead of reading it at an angle and not being able to tell what the volume is. And also, when we're looking at a graduated cylinder, we need to read the volume from the bottom of the meniscus. This meniscus forms because of the liquid's attraction to the side of the graduated cylinder, and it starts to draw up the side. That forms this meniscus, and we have to read from the very bottom of that meniscus. And if you guys will look at that graduated cylinder and count the marks up, we can see that the bottom of the meniscus in this case reads 14 milliliters. Alright, now that we know how to get the volume of a liquid, we're going to look at how to measure the volume of solids. The first type of solid that we're going to look at is a regularly shaped solid. And this is a solid with flat sides that you can measure using a metric ruler. And what you'll do is measure the length, the width, and the height of these objects and multiply them together. The units that we use are meters and centimeters. So let's take a look at this cube down below. We have a length of 10 centimeters, a width of 8 centimeters, and a height of 9 centimeters. So we're just going to plug those in, length times width times height, and we'll have 10 times 8 times 9, and that equals 720. And 720 centimeters cubed, you might be asking yourself how we got centimeters cubed. When you multiply, you can multiply these numbers, 10 times 8 times 9 to get 720, but you can't multiply cm times cm times cm. So we have to bring those units and represent them in our answer. So we have 3 centimeters, 1, 2, 3 here in our equation. We also need to represent those 3 centimeters in our answer, so we represent them as centimeters with a 3 here, or centimeters cubed. And the next type of volume we're going to talk about is volume of a regularly shaped solid. Now these solids are solids that do not have flat sides, and you cannot measure with a metric ruler. So we have to measure those in a process called water displacement. And basically what we do is we put that object in water and see how much the water level rises, and that's going to be determined what the volume of that object is. So let's look at the steps here. We're going to measure out enough water to completely submerge the object. In order for this to work, the object has to be completely underneath the water. You will gently place the object in the water. If you're using a graduated cylinder, this would mean that you probably want to tilt the graduated cylinder to the side and slide that object down the side of the cylinder so that, one, you don't splash water out so your measurements are accurate, and two, the object doesn't hit the bottom of the graduated cylinder and risk breaking the graduated cylinder. The third thing we'll want to do is measure the amount of water displaced, and to do that we're going to subtract the starting volume, so what we started with. We're going to take that away from the ending volume, what it is after we put the object in, and the difference between those two is going to be the volume of our irregularly shaped object in centimeters cubed. And the third property of matter that we want to talk about is density. And remember, we said density is a property of matter that's based on the mass and the volume of an object. So density is the amount of matter in a given space. We can also say that density would be the compactness of matter, or how compact it is in a specific area. To learn more about that, we are going to watch a short video from our friend Mr. Anderson.
Hi, it's Mr. Anderson, and this is AP Physics Essentials Video 16. It's on density, which is a measure of the compactness of matter. And so what we have here are a number of fluids that have different densities. At the bottom, we have maple syrup, followed by dish soap and water and wine and vegetable oil and olive oil. And so what do we know? Well, the most dense material, the maple syrup, is going to be at the bottom, and the least dense is going to be the olive oil at the top. And so matter has a property called density, which measures the compactness of that matter. And so it's affected by mass. And so let me show you a couple of different objects. So we've got object 1, object 2, and then object 3. And so what those circles represent inside the squares is they represent the atoms inside that matter. And so if I were to ask you a question, which of these three have the greatest mass, your tendency is to say this one over here has the greatest mass. But if you look at it, they all have the same amount of atoms, and so they're all going to have the same mass. And so just mass alone doesn't tell us anything about the compactness. What do we need? We also need to divide that mass by the volume. And so we set it up as an equation where density is equal to mass over volume. And since the mass in all of these is remaining constant, the larger the volume is, which is going to be in the denominator, then the smaller our density is going to be. And so this would be the one with the smallest density, and then this would be the one with the highest density, or it's the most compacted of all the matter. And you should be able to calculate density given objects. And so if we look at a bowling ball and a volleyball, and I were to ask you which one has more density, well, you would know that that bowling ball has more material on the inside. If we were to cut it open, you would find that the volleyball is empty. It's filled with mostly air, but that bowling ball is going to be filled with lots of matter on the inside. And so now, even though the volumes are the same, since the mass of the bowling ball is much higher, it's going to have a greater density. So you should be able to make predictions just by looking at objects, and even looking at how objects change over time. What would happen to the density of a volleyball as we heat it up and those molecules move apart? It would become less dense, and as we cool it down, it's going to become more dense.
All right, so what did we learn in that video? Well, we learned that density is the amount of mass in a specific volume, and it can be calculated with an equation, mass divided by volume. So let's see if we can use that equation to calculate the density of an object. Take this problem, for example, and we'll practice with it. A marble has a mass of 12 grams and a volume of 4 milliliters. What is the density of the marble? And we can tell that our mass is 12 grams. We know that's definitely the mass because mass is measured in grams. We know we have a volume of 4 milliliters, and we know that's definitely the volume because volume is measured in milliliters. So to find the density, we need to do mass divided by volume, and the mass is 12 grams. The volume is 4 milliliters. So our next step, we'll replace mass and volume with the actual units of measurement. And we can actually divide 12 divided by 4 and get 3. But just as our multiplication problem earlier, we can't do anything with these units. we can't divide grams by milliliters, or we can't divide a G by an ml. It just doesn't work. So we have to represent those two units in our answer. So we got 12 divided by 4 is 3. And then we leave the grams over the milliliters, and we write this as 3 grams per milliliter, which literally means that there are 3 grams of matter in every milliliter of volume. And that is a measure of compactness, a measure of density. So now that we've had a chance to work a problem together, I want you guys to try it on your own. So here in just a second, I'm going to ask you to pause the video and try the problem below. Let's read that together. An object has a mass of 50 grams and a volume of 10 milliliters. What is the density of the object? Now remember from before, density equals mass over volume, or mass divided by volume. So right now I want you to pause the video and see if you can calculate the density of this object. Remember how we should write our units, and please try to show your work. Welcome back. Now let's take a look at the answer and how we calculate that problem. Welcome back. Now that you've had a chance to calculate the density of this object, let's take a look at how we got there. Alright, so I know once again that I'm going to lay out my problem like this and show my work. Density equals mass over volume, or mass divided by volume. The mass in this equation was 50 grams, and the volume was 10 milliliters. So we know 50 and 10 are numbers, so we can divide those. 50 divided by 10 is 5, so I can move that to my answer, but I cannot divide grams by milliliters or G by ml, so those have to be represented in my answer. I move G over ml to my answer, G over ml, and I have 5 grams per milliliter, which, like we said, literally means that there are 5 grams per every milliliter of volume, and that is the measurement for density.